Hello and welcome to BrushMyQuant channel. Today we'll talk about functions and custom characters. We'll start with the definition of function. We'll go through domain and range of a function. Then we'll look into a couple of problem types. So the first one is finding f of a constant. Example, f of x is equal to 3x plus 1 and we have to find the value of f of 2. The second problem type is on reciprocal problems. Example, f of x is given to you and we need to find the value of f of 1 by x. The third one is on nested functions problems. So two functions like f of a and g of a are given to us and we need to find the value of f of g of x. The fourth one is on simultaneous equation problems. Example, f of x is equal to ax square plus bx and values of f of 1 and f of 2 are given to us and we need to find the value of f of 3. The fifth one is on symmetric functions problems. Example, for which of the following functions is f of x is equal to f of 1 minus x. And the last one is on custom character problems. So let's start with the definition of functions. So function is a relation which takes an input and gives a unique output for that input. Let's take an example. So let's say I have a function f of x is equal to 2x plus 1. Now what we mean here is when I put value of x as, let's say x is equal to 1, then I'm going to get a unique value of f of 1, which is nothing but 2 into 1 plus 1, which is nothing but 3. So for every value of x, we are going to get a unique value of f of x. Now let's go back a bit and see how exactly we got value of f of 1. So f of x was given to us as 2x plus 1 and we know that x is equal to 1. So we will see what is inside the bracket. So right now inside the bracket we have x and we know that x is equal to 1. So wherever we have x on the right hand side, we are going to replace that x with 1. And that's what we have done here. And that's how we got the value of f of 1 as 3. Now let's talk about the domain and range of the function. Now the domain of the function is the set of values which the independent variable, that is x in f of x, can take, for which the dependent variable, which is f of x, has a valid value. That means the value of the function should not be undefined. Let's take an example. So let's say f of x is equal to 1 divided by x minus 2. Now we know any fraction becomes undefined whenever the denominator is equal to 0. That means this function will become undefined when the denominator is 0, which is nothing but x minus 2 is equal to 0 or x is equal to 2. So this means that x can take all the values apart from x is equal to 2. So the domain for this function will be x belongs to all the real numbers and x cannot be equal to 2. Let's talk about the range now. So range is the set of resulting values of the function f of x for all possible values of x in the domain of f of x. Let's take an example. So f of x is given to us as 1 divided by x minus 2. Now we know that the domain is x belongs to all real numbers and x cannot be equal to 2. That means if I take any value of x in this and substitute in f of x, whatever corresponding value of f of x we are getting, that value is nothing but in the range of f of x. Let's take an example. So if we put x is equal to 3, we are going to get f of 3 as 1 divided by 3 minus 2, which is nothing but 1. That means 1 is one of the possible values in the range of f of x. So we need to substitute all the values of x, which is in the domain, get the corresponding values of f of x, and that becomes the range of the function f of x. Let's solve a couple of problem types now. So the first problem type is on f of constant problems. The question given to us is f of x is equal to 3x plus 1 and we need to find the value of f of 2. Now we are going to see what is given to us. So f of x is given to us and they are asking f of 2. If you compare the things inside the bracket, here I have x and here I have 2. That means wherever I have x on the right hand side, I'll replace that with 2 to get the value of f of 2 as 3 into 2 plus 1, or nothing but 6 plus 1, or 7. Let's try the next one. So if f of x is equal to x plus 3 divided by 2x minus 6, where x is not equal to 3, then find the value of f of 5. Again, we'll see what is inside the bracket. Here I have x inside the bracket and I have to replace that with 5. So let's do that. So wherever I have x on the right hand side here, I will replace it with 5 to have f of 5 as 5 plus 3 divided by 2 into 5 minus 6, which is nothing but 8 divided by 10 minus 6, or 8 by 4, or 2. So remember, whenever we have to solve f of constant problems, we just need to see what is inside the bracket in the definition of the function and what is asked to us. Whatever is the value you're looking for, replace that value with x on the right hand side. Let's try a couple of more problems. So if f of x is equal to 2x square plus 5 and f of a is equal to 13, then find the value of a. Again, we'll see what is inside the bracket. Here we have x and they are asking us to replace that x with a. So f of a will become 2a square plus 5, and that is given to us as 13. Let's take 5 to right hand side. So we'll have 2a square is equal to 13 minus 5, which is 8, or a square is equal to 8 by 2, which is nothing but 4. That means a can be plus minus 2. Let's try the next one. F of x is equal to 5x minus 1 divided by 3x minus 7, where x cannot be equal to 7 by 3. And f of a is given to us as 7. And we need to find the value of a. So again, let's see what is inside the bracket and replace that with a. So we'll have f of a is equal to 5a minus 1 divided by 3a minus 7. And that is given to us as 7. Let's cross multiply. And we'll have 5a minus 1 is equal to 7 times 3a minus 7, or 5a minus 1 is equal to 21a minus 49, or 49 minus 1 is equal to 21a minus 5a, or 48 is equal to 16a, or a is equal to 48 by 16, which is nothing but 3. Let's try the next problem type. So the next problem type is on reciprocal problems. The problem is if f of x is equal to 2x plus 1, then find the value of f of 1 by x. Again, we'll see what is inside the bracket. Here I have x and I have to replace that with 1 by x. So f of 1 by x will become, replace x with 1 by x, 2 into 1 by x plus 1, which is nothing but 2 by x plus 1, or if you take the LCM, 2 plus x by x. So remember, when you have to find the value of f of 1 by x, you just need to replace x with 1 by x in this function. Let's try one more. So if f of x is equal to x minus 2 by 3x plus 4, then find the value of f of 1 by x. Again, we'll see what is inside the bracket. So I have to replace x with 1 by x to get f of 1 by x as 1 divided by x minus 2 divided by 3 divided by x plus 4. And if you take the LCM, 1 minus 2x by x divided by 3 plus 4x by x, which is nothing but 1 minus 2x. This x will go up and this x will go down, multiplied by x divided by 3 plus 4x multiplied by x. This x will cancel out and our final answer will be 1 minus 2x divided by 3 plus 4x. Let's try next problem type. So next problem type is on nested functions problems. The question is, if f of a is equal to a square and g of a is equal to a cube, then find the value of f of g of x. Now this is called as nested function because one function is inside the other. So let's first find the value of the inside function. We know g of a is equal to a cube, and they're asking us value of g of x. So we'll replace a with x to have g of x as x cube. Now we can write f of g of x as f of x cube. We already know the value of f of a as a square. So we need to replace a with x cube, and we'll have x cube whole square, or nothing but x raised to 3 into 2, or x raised to 6. Let's try one more. So if f of x is equal to 2x minus 3 and g of x is equal to x cube, then find the value of f of g of x. Let's try to find the value of g of x first, which is already given to us as x cube. So let's replace that. So that becomes f of x cube. And we know the value of f of x as 2x minus 3. We'll again compare what is inside the bracket. So we have to replace x with x cube and have this value as 2 of x cube minus 3, which is nothing but 2x cube minus 3. Let's try more problems. So f of x is equal to 2x plus 3 by 3x plus 5 and g of x is equal to 3x minus 2. Then find the value of f of g of 2 and g of f of 3. Let's try the first one. So f of g of 2. Let's first find the value of g of 2. We'll compare the brackets. So we have to replace x with 2 to have g of 2 as 3 into 2 minus 2, which is 6 minus 2, or nothing but 4. That means f of g of 2 is equal to f of 4. We'll again compare the brackets and replace x with 4 to have 2 into 4 plus 3 divided by 3 into 4 plus 5, which is nothing but 8 plus 3, 11, and 12 plus 5, 17. Let's try the next one, g of f of 3. We'll first find f of 3. So we'll replace x with 3 here to have f of 3 as 2 into 3 plus 3 divided by 3 into 3 plus 5, or nothing but 6 plus 3, 9 divided by 9 plus 5, which is 14. Now g of f of 3 becomes g of 9 by 14. 3 into 9 by 14 minus 2, or nothing but 27 minus 14 into 2, which is 28 by 14, or minus 1 by 14. Let's try one more. So if f of x is equal to 3x minus 2 and g of x is equal to x squared, then for what values of x is f of g of x is equal to g of f of x? Let's first find out the value of f of g of x. So if we replace g of x, it becomes f of x square, which is nothing but 3x square minus 2. Let's find value of g of f of x. So if you replace f of x, it becomes g of 3x minus 2, which is nothing but, if you replace x with 3x minus 2, 3x minus 2 whole square. And it is given to us that f of g of x is equal to g of f of x. That means these two values are equal. So 3x square minus 2 is equal to 3x minus 2 whole square. Let's use a minus b whole square. So that becomes a square minus 2ab plus b square, which is nothing but 9x square minus 3 into 2, 6 into 2, 12. So 12x plus 4, and that is equal to 3x square minus 2. Let's take 3x square to right hand side. We'll have 6x square. 2 to right hand side, we'll have plus 6 is equal to 0. If you take 6 common in this becomes 6 times x square minus 2x plus 1 is equal to 0. You can divide both the sides by 6. And this is nothing but x square minus 2x plus 1, which can be written as x minus 1 whole square is equal to 0. That means your value of x is equal to 1. So for x is equal to 1, f of g of x will be equal to g of f of x. Let's try the next problem type. So the next problem type is on simultaneous equation problems. Let's try the first one. So if f of x is equal to a plus bx and f of 1 is equal to 6 and f of 2 is equal to 10, then we need to find the value of f of 10. So let's find the value of f of 1 first. We'll replace x with 1. So f of 1 will be nothing but a plus b into 1, which is nothing but a plus b, and that is given to us as 6. F of 2 will replace x with 2. So f of 2 will be nothing but a plus b into 2, which is nothing but a plus 2b is equal to 10. Now we have these two simultaneous equations. If you subtract the first one from the second one, you'll have a plus 2b minus a plus b is equal to 10 minus 6, which is nothing but 4. A will cancel out and you'll have b is equal to 4. You can substitute in this. If b is 4 and a plus b is 6, that means a will be equal to 2. So our function becomes f of x is equal to 2 plus 4x, and we need to find the value of f of 10. So we'll put x is equal to 10 here and have 2 plus 4 into 10, or nothing but 40 plus 2 or 42. So to solve this kind of problems, we need to substitute the values given to us. We need to figure out a function and use that function to find out the answer which we are looking for. Let's try one more. So f of x is equal to ax square plus bx and f of 1 is equal to 10 and f of 2 is equal to 30. Then we need to find the value of f of 3. Let's put x is equal to 1 first. So f of 1 is equal to a into 1 square, which is 1, plus b into 1, which is b, is equal to 10. Let's put x is equal to 2. So f of 2 will become a into 2 square, that becomes 4a, plus b into 2, that is 2b, is equal to 30. Now we have simultaneous equations. Let's multiply the first one by 4 and we'll have 4a plus 4b is equal to 40. And the second one is 4a plus 2b is equal to 30. If we subtract both of them, 4a will cancel out and we'll have 2b is equal to 40 minus 30, which is 10. That means b is equal to 10 by 2 or b is equal to 5. If you substitute b is equal to 5 in this, you'll get the value of a also as 5. That means the function is f of x is equal to 5x square plus 5x. Now we need to find the value of f of 3. So we'll put x is equal to 3 in this to have 5 multiplied by 3 square plus 5 into 3, which is nothing but 5 into 9, 45, plus 5 into 3, which is 15, which is nothing but 60. Let's try the next problem type. So next problem type is on symmetric functions problems. Let's try the first one. For which of the following functions is f of x is equal to f of 1 minus x for all values of x? And a couple of functions are given to us. So how we are going to solve this is we need to find out the value of f of 1 minus x for all of these functions and see for which of those functions f of x is equal to f of 1 minus x. Let's try the first one. So to find f of 1 minus x, we are going to replace x with 1 minus x to have 1 minus x whole square. We'll use a minus b whole square, which is nothing but a square. So 1 square, which is 1, minus 2 into a into b. So minus 2 into 1 into x, which is minus 2x, plus b square, which is x square. Definitely x square is not equal to 1 minus 2x plus x square for all values of x. So this is not true. Let's try the second one. So f of 1 minus x will become 1 minus x plus 1, which is 2 minus x. Again, x plus 1 is not equal to 2 minus x for all values of x. So this is not true. Let's try the third one. F of 1 minus x is equal to 2 times 1 minus x plus 1, which is 2 minus 2x plus 1. So 3 minus 2x. So 2x plus 1 definitely is not equal to 3 minus 2x for all values of x. So this is also not true. So answer should be the fourth one, but still let's try it out. So f of 1 minus x will be 1 minus x multiplied by 1 minus x, which is nothing but 1 minus x multiplied by 1 minus 1 plus x. or nothing but 1 minus x multiplied by x, which is same as f of x. So this is true. So to solve this kind of problems, you need to replace x with 1 minus x and see for which of the following functions f of x is equal to f of 1 minus x. Now this is a lengthy process. So let's see if there is a theory for this. So what kind of functions are symmetric? So f of x is equal to f of 1 minus x when fx is symmetric in terms of x and 1 minus x. Let's see what do I mean by symmetric in terms of x and 1 minus x. So if there is a term of x in the numerator of f of x, then there should be a term of 1 minus x also in the numerator with the same power and the same sign. Example, in the previous problem, we had f of x is equal to x into 1 minus x. So we have a term of x in the numerator and 1 minus x also in the numerator with the same sign and the same power. So they have the same power of 1 and the same sign which is positive. So that means f of x is symmetric in terms of x and 1 minus x. Now the next one is, if there is a term of x in the denominator, then there should be a term of 1 minus x also in the denominator with the same power and the same sign. So let's take an example. F of x is equal to 1 divided by x into 1 minus x. Again, I have a term of x in the denominator and also 1 minus x in the denominator with the same power and the same sign. That means this function is symmetric in terms of x and 1 minus x. And for this function, f of x will be equal to f of 1 minus x. Let's take some examples to understand this. So let's talk about some of the symmetric functions. So the first one, f of x is equal to x square multiplied by 1 minus x whole square. Here I have a term of x in the numerator and also 1 minus x in the numerator with the same sign, which is positive, and the same power. That means this function is symmetric in terms of x and 1 minus x, and f of x will be equal to f of 1 minus x. The second one, f of x is equal to x square plus 1 minus x whole square. Again, I have a term of both x and 1 minus x in the numerator with the same sign, which is plus, and the same power, which is 2. So this is also symmetric in terms of x and 1 minus x. Let's try the third one. F of x is equal to 1 divided by minus x cube multiplied by minus of 1 minus x whole cube. Here also I have x in the denominator and 1 minus x also in denominator with the same sign, which is negative, and the same power, which is 3. So f of x is symmetric in terms of x and 1 minus x, and f of x will be equal to f of 1 minus x. Let's see some of the non-symmetric functions now. So the first one, f of x is equal to x square multiplied by 1 minus x whole cube. Now I have a term of x and 1 minus x in the numerator with the same sign but different powers. That means this function is not symmetric in terms of x and 1 minus x. So f of x will not be equal to f of 1 minus x. The second one, I have a term of x and 1 minus x in the numerator with the same power but with different signs. So this is also not symmetric in terms of x and 1 minus x. The third one, I have a term of x and 1 minus x in the denominator with the same power but with different signs. So this is also not symmetric in terms of x and 1 minus x, and f of x will not be equal to f of 1 minus x. The fourth one, I have a term of x in numerator but 1 minus x in denominator. So that means it is also not symmetric in terms of x and 1 minus x. Let's look at the next problem type now. So next problem type is on custom character problems. Let's try the first one. So if a at the rate b is equal to a square minus 2ab, then find the value of 2 at the rate 3 at the rate 1. Now this at the rate can be read as a function where it is a function of a and b, and it is equal to a square minus 2ab. Using PEMDAS, we need to find the value inside the parenthesis first. So let's solve for 3 at the rate 1. So if you compare these two, I have a value before at the rate, which is 3, and a value after at the rate, which is 1 in this case. So wherever I have a, I will replace it with 3. And wherever I have b, I'll replace it with 1 to get the value of 3 at the rate 1 as 3 square minus 2 into 3 into 1, which is nothing but 9 minus 6 or 3. That means my problem becomes 2 at the rate 3. Again, I'll compare this with this. That means my value of A, which is before at the rate, becomes 2, and the value of B, which is after at the rate, becomes 3. So this becomes 2 square minus 2 into 2 into 3, which is nothing but 4 minus 12 or minus 8. So our final answer is minus 8. Let's try the next one. If A square B is equal to B square A for all values of A and B, then what can be the possible operation square? So the first one says addition. That means A plus B is equal to B plus A. We know that is true for all values of A and B, so that is correct. Second is multiplication. That means A into B should be equal to B into A, which is also correct for all values of A and B. The third one is division. That means A divided by B is equal to B divided by A. Definitely that doesn't have to be true for all values of A and B, so that is false. And the last one is subtraction. That means A minus B is equal to B minus A. Again, that doesn't have to be true for all values of A and B. So our answer is 1 and 2 are correct. Let's try more problems. So if A hash B is equal to A plus B minus 2AB, then find the value of 4 hash 2 hash 1 hash 3. Let's first find the value of 4 hash 2. So we'll compare it with A hash B. We have A before the hash, that means A becomes 4, and B after the hash, so B becomes 2. So 4 hash 2 will be nothing but 4 plus 2 minus 2 into 4 into 2, which is 6 minus 16 or minus 10. Let's find 1 hash 3 now. So we'll replace A with 1 and B with 3 to have 1 hash 3 is equal to 1 plus 3 minus 2 into 1 into 3, which is nothing but 4 minus 6 or minus 2. That means our problem becomes minus 10 hash minus 2, which is nothing but we'll replace A with minus 10 and B with minus 2 to have minus 10 minus 2 minus 2 into minus 10 into minus 2, which is minus 12 minus 10 into minus 2 becomes plus 20 into minus 2 becomes minus 40. So which is nothing but minus 52. Let's look at the answer choices. So 2 hash 3, 3 hash 4 and so on. So they have given the answer choices also as the function. So we need to solve for each and every answer choice and see which one gives us minus 52. Let's try the first one. So we'll replace A with 2 and B with 3 to have 2 plus 3 minus 2 into 2 into 3, which is nothing but 5 minus 4 into 3 is 12, which is minus 7. So it is not true. Let's do the second one. Replace A with 3 and B with 4 to have 3 plus 4 minus 2 into 3 into 4, which is nothing but 7 minus 3 into 2 is 6. 6 into 4 is 24, which is minus 17, which is also not true. Let's try the third one. So replace A with 4 and B with 8. So 4 plus 8 minus 2 into 4 into 8, which is nothing but 12, minus 8 into 4 is 32 into 2 is 64, which is minus 52, which is the correct answer. But let's try the last one. So 1 plus 2 minus 2 into 1 into 2, which is nothing but 3 minus 4, which is minus 1. So our answer is option number 3. Let's try more problems. So solve for diamond and square in the below subtraction equation, given that diamond and square are single digit numbers. So they have given us a subtraction equation and the result is 500 something. And we have to find the value of this rhombus and the square. Now I'm subtracting two numbers, a 3-digit number and a 2-digit number, and getting a 3-digit number, which is 57 something. So definitely when we are talking about this rhombus, this has to be either 5 or 6. Let's try with that rhombus as 6 first and see what do we get. So 664 minus square and 6 here, this gives us 57 square. Now I have to add something to 6 to get 4, which is nothing but I need to add 8 to 6 to get 14. That means this becomes 664 minus 86 is equal to 578. Let's check it out. So we can just add 86 and 578 and let's see whether we get 664. So 8 plus 6 is 14. Then this becomes 16 and 664, which is this. So that means this is correct. So whenever you have problems like this, you need to start assuming values for the variables which you're solving for and consider those cases and then start forming your solution. Let's try one more. So solve for diamond and square in the below multiplication equation. And it is given that diamond and square are single digit numbers. So we are multiplying two two-digit numbers, one in 30s and other two-digit number to get 1500 something. We know 30 multiplied by 50 is 1500. That means this number should be either 42 or 52. Because if it is 60 something, then it will cross 1800. And if it is 30 something, this will be somewhere around 1000. So this can be 42 or 52. Let's try with 52 first. So we have 3 diamond multiplied by 52 and it gives us 1555. Now to multiply 2 with some number to get 5 as the unit digit. We know that is not possible because 2 is already an even number and 2 multiplied by something can never give us an odd number. So 52 is not possible. So let's try with 42. So 3 diamond multiplied by 42 is equal to 1554. So we have to multiply 2 with something to get 4 as the unit digit. That means this can be 2 or this can be 7 to give us the unit digit as 4. Let's try with 2 first. So 32 multiplied by 42. Let's do the multiplication. 2 into 2, 4. 6. 4 into 2, 8. 4 into 3, 12. 4. 8 plus 6, 14. 1344. But we were looking for 1554. So this is not correct. So let's try with 37. So 37 multiplied by 42. 2 into 7, 14. 2 into 3, 6 plus 1, 7. 7 into 4, 28. 4 into 3, 12 plus 2, 14. Which is nothing but 4, 5, 5, 1. Which is what we were looking for. So that means diamond is equal to 7 and square is equal to 4. So to solve this kind of problems, you need to take the possible cases first and then you need to try it out to get your final answer. Hope you are able to understand the theory of functions and know about the domain and range and what are the types of problems which typically comes in functions and custom characters. If you did, please go ahead and like the video, provide your valuable comments, and please do share this video with your friends and subscribe to this channel. Thank you.